This question, we are trying to find the fastest speed of the rocket, and we're going to use this by doing calculus, which means we need to write down a few steps. So what we're assuming is that the rocket goes up and then down, and the acceleration follows this kind of crazy equation here. Okay, so we do need to know that from launch, when we launch this thing, t is equal to 0. All right. And so what we're going to do is we need to determine the fastest speed. We're given acceleration, but we want to find velocity with respect to time. All right. Now, velocity is equal to the integral of acceleration. Okay. And whenever we integrate something indefinitely, we're always going to need to remember that plus c. And to solve for plus c, we need to be given an initial point. We do have one because when at rest, at exactly t is equal to 0, our velocity should be equal to 0. Likewise, our acceleration should be equal to 0. Likewise, our displacement should be equal to 0. Okay, so we'll need to write down just the first bit to say that our velocity t is equal to the integral, and now I'm going to write this all out, and I'm going to use my calculator, okay? Because otherwise it's a bit too difficult. dt. All right, so let me bring up the calculator. All right, so I'm not sure why it's done that. But you can see I have been doing a few of these. So I'm just going to paste this in here, otherwise it's going to take me too long to write, and I am going to put that minus sign, which does exist there. Okay, so to find the derivative of this, you're going to need to go interactive, calculation, and integrate it, but find the indefinite integral. Okay, and that gives me this value here. So that value I am going to write in. So we can say that we have found the velocity, okay? And that is equal to, if you noticed, I used x, but really we write t here. So it's just easier to use x because x is like quite accessible. And I'll just write out the rest of them here. Okay, and then we just need to have plus c. So I want to make this really clear. You have to write plus c, and because we're using calculus, we're going to have to solve for it. So we say v of 0 is equal to 0, and we say solve for c. So you can write out the equation, or you can just punch in the answer using the calculator, or we can say 0 is equal to 0 0 0, and that is meant to be a plus. 0 Okay, so now we can say use calculator. Okay, and we can say C is equal to, now we're just going to do this on the calculator because it is so much easier. So I'm just going to pop this down here and I'm going to say that all of this is equal to 0, right? But we're going to have to solve for this value C. So all of this is equal to 0. We need to substitute out all the values of x. So you can either like manually go in here, right? Like, backspace and put 0. In fact, maybe that's easier for you. If you want to get real fancy, you can go down to Math 3 and use this given that sign and say that x does equal to 0. Okay? And then we just need another variable to represent our plus c. Okay, so I can write plus c here. All right, so now I can highlight this whole thing and go interactive, uh, advanced and solve. And I want to instead solve for x. I want to solve for value c. Okay, and it says that c is equal to minus 2 times the square root of 5. Okay, so we go back here and we say that this is minus 2 square root of 5. All right, so now what we need to do is we've got the velocity. We need to find the maximum one, and that occurs when the derivative is equal to 0. So we can say that max velocity occurs, right? So maximum velocity, max velocity when, all right? But let's just double check. What does this thing look like when we graph it? Okay, so we can grab our value in here, stick him in, and also say plus all of that. And I'm just going to copy. Oh, that is unfortunate. Undo, copy, graph and table. And then I want to pull up this. And it looks like a lot's happening there. Okay, so we can zoom out, zoom out, zoom out. And we can see that there's this big peak here. So it kind of goes like, zoom out. And I'm just adjusting the axis so you can see this properly. Okay, so we can see that at this point here, that's where a maximum speed would occur. Okay, so that's what we're trying to find, but that occurs when our displacement is equal to 0. All right, so now we need to differentiate it. So we can say that that's when our uh, acceleration is equal to 0. So all of this is equal to that. So we need to kind of solve when does our acceleration equal to 0? So that's when we kind of go up to the top and write this down that um, 0 is equal to And I'll just t minus t root 3. Okay, and so we say use calc. All right, so use calc, and we're going to get multiple values because as you saw from the graph, there was multiple values that we could use, minimums or maximums. So again, we're going to go into our main. I'm going to grab this one here, grab this one here, and pull that down. I might just, in fact, cut this, clear all, paste that, and say that is equal to 0. And I want to use solve for our values. So advanced solve, I want to solve, and we get a couple of values here. So we get minus 0.45 at 0, and then 6.21. And if we go back into here, into our graph, apologies, we get that this is at 6.21. So that's good. That's on the right track. All right, so we can say t is equal to minus 0.45, I believe it was, 0, and this 6.21. We have to say that our value t must be greater than or equal to 0. And we know that, well, it has to be greater than 0. So t is therefore equal to 6.21. All right. So now that we know that, we can then substitute our value into velocity. All right. So it's a lot of work, I know, but we then find V max, or our max, occurs at 6.21. Okay. So then we substitute in, use our calculator, and then just substitute that value in there. And we can even use graph and tab here to use that 97 value that we used before. So you can either use it in main or just put it straight in there. Okay, and then after we've done that, and that's in meters per second, that is our answer. Perfect, so a bit of a long one, but really when we do these sorts of things, there's a couple of steps that we need to do. First step is we do the integration or whatever we need to do here. So that was this step here. We need to have the plus c. We then need to solve for it. So that's that step. And then what we need to do is differentiate it to find our stationary point. And then you will need to, I guess, like prove that, but we have used calculus here, and it is a very long-winded question. So I've left it there, but hopefully that explains how to do these sort of long questions.